సార్ సార్ తెలుసు మెయింటైన్ సైలెన్స్ ఓకే యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం అది అవును సార్ యాక్చువల్గా 3:30కి మనది వ్యాలిడిటీ సార్ బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్. యాక్చువల్ గా 3:30కి మనది వ్యాలిడిటీ సార్. బిఫోర్ 30 మేడం ఆన్లైన్ సెషన్ అవ్వాలి. ఇక్కడ అవైలబుల్ గా ఉంది. ఇక్కడే చేసేస్తాం. సార్ యాక్చువల్లీ ఇక్కడే అనుకున్నాను 2 o'clock టైం. అది అవును సార్.
సరే లైవ్ చెక్ చేసుకుందాం వాయిస్ లైవ్ అని ఏం మాట్లాడడం మాట్లాడ రిప్లై చేస్తున్నా
Morning, everyone. On behalf of the Department of Electrical and Electronics Engineering, Worthman College of Engineering, I extend a warm welcome to all dignitaries, faculty members, students, and participants joining us for day 3 of the AI Grid Summit 2026. Global Resilience and Intelligence in Distribution. AI for Smart Grid, an officially affiliated pre-summit event of the India AI Impact Summit 2026, India AI. Over the past 2 days, the summit has witnessed insightful discussions on artificial intelligence applications in smart grids, energy efficiency, and intelligent power distribution systems. Building on these discussions, Day 3 focused on the challenges and opportunities associated with integrating artificial intelligence into renewable energy systems and modern power networks. We now proceed with today's technical session titled Renewable Energy AI Integration Challenges. Session highlights the practical operation and system level challenges involving deploying AI driven solutions for renewable energy integration. coordination, and sustainable power distribution. It's a privilege to introduce our esteemed resources person for this session, Professor Anil Nayak. Professor Anil Nayak is an assistant professor at the National Institute of Technology, Warangal. He has strong academic and research expertise in the areas of renewable energy systems, power system operations, smart grid, and energy integration challenges. His work focuses on addressing real world issues related to renewable energy penetration, grid stability, and intelligent control of power distribution networks. Professor Anil Nayak has been involved in teaching, research, and academic mentoring and has contributed to various technical discussions, workshop, and knowledge sharing platforms in the domain of sustainable and intelligent energy systems. These sessions are known for their clarity, technical depth, and practical relevance, making complex concepts accessible to students, professors alike. We are grateful to Professor Anil Nayak for joining us today and sharing his valuable insights with us. I'm going to talk about the sir.
Okay, now there is a more flexibility choices we have. There is one advantage. Another objective is that utilities to reduce the peak demand as well. So when that maximum demand is happened, it is one of the example which will happen in the 2024 or 23 in the India. Maximum demand is almost 250 megawatt was happening. It is also successfully automated by Indian grid because they have the information. There is a ISO, there is a customers, the generation. If the coordination is happened between them, this kind of peak demand can be reduced. There is another objective. Like the third objective is that utilities to reduce the carbon dioxide emissions. Because when the utility is going for more and more power generation, obviously they are opting to go with the PV or renewable energy sources, something like that. Since some of the industries revolution have started something, the first revolution was it is the first mechanical based and through production was happening. The second one is through introduction of division labors and it is with electricity energy. Mostly the electrical energy has been started as the first, second generation. Third generation has started with the electronics and IT system that further automated into further. So like that, whenever the generation has started, when the revolution has come into your systems, that every time the same kind of technology has been adopted into your power system. Now we are at the right, fourth generation. Go back. Now we are at this fourth generation where almost AI and ML is going to be working on that. Okay? Now come to the definition, the power system automation, how the people are defining the power system automation. Power system automation is automatically controlling the power system through some instrumentation and controlling devices. We know that we have CTs and PTs or some kind of microcontrollers and PLCs. By make use of that, we try to doing that one. Our power system automation is a system for managing, controlling and protecting the various components connected in the power system. When you define the power system is a I can say it is a various components which are connecting together in the working in a coordination manner, try to delivering the power from supply to. That is what it is doing. Where your power system automation try to controlling, protecting all sort of equipment also. This is also another definition of that one. Power system automation is the execution of various tasks in the substations, generating stations, and power distribution systems without human interference. That is what the power system automation is doing by that. And some of the advantage why you want to go for the automation here is that, of course, it increase the productivity. If I go with automation, it is not only the automation is not only confined with the power system, it is there in the other domains, something like machinery process, factories, heating ovens, telephones, networks, steering, stabilization, ships, aircrafts, and other applications. Similarly, the same technology has been adapted into your power system in order to increase the productivity in terms of the maximum energy generation with optimal direction, improve the quality. That is called the power quality. How you are trying to best try to supply your power quality to that customers. Improve the robustness of the process. Or I can say it is a robustness to the power system. And you have to design your power system in such a way that, or your power system in such a way that any event is happening into your power system, it should be a very strong enough to stand for that particular abnormal conditions and increasing the consistency in the output also. It's a power system will be more reliable, something like that. Of course, reduce the direct human labor cost and also the expenses. That is also going to be doing by that. And actually, how this evaluation has started. Generally, when you see power system evaluation, it was started with a initial control equipment with an analog devices with a big one. So example is that when you are seeing the computers, the first generation computers, There are some, there are mostly some kind of solid state electronic devices they have been designed. Size of those computers are such a this much of a big group, right? So that is the larger size. Now the today what we have the computers between the hands, very small. The space or something like the size we got it. Same thing has been evaluated during that time has running with fuse with n number of many number of wires running from the field to the control center. In the data control in field equipment, generally it is maybe your transformer. Field equipment may be your DGs, distributed generators, or the field equipment can be anything, whatever the capacitor or what the equipment you want to control it or to monitor it. Therefore, in order to control this particular field equipment, there are many number of wires are running from cables. When you say the data control center is here, and we want to control the different field equipment from this control center to a lot of control cables is being running. So a lot of space is occupied, and also the lot of wires and complexity has been done. So the latter point of time, there is a the development has come in terms of digital computing. The digital computer has came, its problems has been solved, but another problem has been came to here is it is that it is with a limited memory. When you see that 10 years or 15 years back, what is the RAM size or what is the speed of your computer was that in terms of MBs, and in terms of MBs or something like that. And what today we have, it is in GBs. In terms of 16 GB RAM, 32 GB RAM. That is the speed of this particular energy development is going to be happening. Same thing is also going to be incorporated into your power system. In other words, I can say that in some devices there is an interoperability operation issues also there. That is also been solved very effectively in this particular systems. Next, so this is the historical image. This is automation. How the automation you can define it? It is a three-layer structure. We have something like this. Generally, the field equipment, the equipment which is we are being to monitor it. Whatever the equipment you want to monitor it, that is going to be your field equipment here. I can touch it like this, right? So when you want to monitor this field equipment, there is a kind of devices which is called RTUs and IEDs, remote terminal units, the intelligent electronic devices, which is being connected over here, try to be connected with the field equipment. Here to the field equipment, this is going to be connected, and some of the switch gears. All these components, which is comes under the level one, where information from the field equipment is going to RTUs and IDUs in terms of digital signals. Plus, some transducers will be placed at the field equipment. And these transducers will convert the signals into in terms of voltage or current signals. And those analog signals further converted into a digital signal through your IEDs and RTUs. And further, the data is going to be processed at the level 2 or a layer 2. Where the layer 2 it has control and protection equipments. These control and protection equipments also need IEDs and RTUs. There is also some IEDs and RTUs are placed in at this particular control and protection equipment, and some kind of alarms also. Any event, something has happened in your complete power system, some kind of alert is going to be happening from that. And this data will going from your level 2 to level 3. The level 3 mainly it is called the data control centers. The data control center are the workstations which is sitting at the higher authority. Let us say in the Delhi we have a power grid, or we can say the grid India is there. So the national level load dispatch center which is sitting at the Delhi, you can be considered as a control center or workstation there. And from there, they are trying to be controlling the field equipment which is which is placing at this college, in Vardhaman Engineering College. Suppose you have the PV solar plant, they want to control from there, they try to controlling it. Monitoring can be done. So this is a process happening in the power system automation. One way, the monitoring and data acquisition, and the data will flow or processed through the control center, and the control center people they try to giving the controlling action back through here. There is actually they try to control the what do you call this particular equipment, something like that. There are two classifications here. It is called the substation, station automation, and the distribution automations. For the substation automations, when we say that it is it is a part of your electrical generation or transmission or something like that, we can say. It is a substation consists of it has some kind of switchgear equipment, or I can say it is has one particular transformer or something like it, 33 kV to 11 kV or some transformer feeders and some reclosers and signalizers, all kind of monitoring devices will be placed in the substation. Here, these are the IEDs will be placed in the substation, and we have a control center, and then the data transfer is happening. So this is how control automation or substation automation is being done in the small substation. So take a small substation where with one IED with a small computer, small data control center, they can able to make everything automated over there. A lot of alarm statuses of the circuit breakers, status of the reclosers, status of the transformer, everything is going to be monitored. Also, measurement is also done. In terms of voltage, current measurements will be done. So this is the direction, the data acquisition and measurement is happening, monitoring is happening, and after that, command is coming from your data control center to the. So this that automation is happening in the world by the substation, and this is one of the automation. Actually, previously there is no numerical relays was there. There is no numerical relays or no microprocessor relays or technology has been developed. In that, in order to make a automation for a very small substation with single line, one transformer, two feeders, require a large panels filled with relay switches and lights. So much. Even today also, the automation which is there in your substation, that is still it is a old one or it is a traditional one. If you go and visit there, you can see a lot of wires is coming from the different equipment. From the transformer one is coming, sectionalizer is coming, and circuit breaker one line is coming. The many cables are running and all connecting together the data control center. So that is, I can say, it is a the space is going to be required fused into that. The today with one single IEDs, that is electronic devices, which is what with one IED you can able to make your complete substation as a become a automation with communication technology with a single high speed line. We have only high speed LAN, high single speed one cable with high speed LAN with one IED. It is sufficient to make your power system become automation. It is how cost and the space is greatly reduced in terms of automation. That is what the technology is doing into that. This is a distribution automation. Generally, distribution automation it is mainly the taking role by their electrical utilities. The main objectives or role of the electrical utilities, what they do, electrical utilities are nothing but the companies. Reliance is the electrical utility, right? Jindal or it is the electrical utility. And these electrical utilities are taking, you know, and they are majority, they try to be making the automation in terms of substation, feeders and consumer devices and loads. Everything is being monitored by these electrical utilities. Under the electrical utilities, One distribution automation system will be there. It is called the data control center. We have it. N number of substations, substation 1, substation 2, substation 3, substation 4, all together substations through feeders and the loads, everything is being connected. From there, the distribution, the electrical utility people who are sitting at the one particular location, they try to controlling this particular substation automation. This is the best example how the electrical utility is doing the distribution automation here. Anything happen, the fault happen, they can able to attend and they can able to know that the particular location, some kind of abnormalities happen, that information is carried out here. They come to know something happens, some switch is opened at this particular location at the house. This is going to be done. So previously, substation itself is automated, and like this substation is also automated. And now all the substations are connecting together through different feeders and lines, and the customers and the consumers loads, everything being monitored by distribution automation system. It is called. I can call this is the a center which is a sub load dispatching center. Let us say NPDCL is there in the Telangana NPDCL is there. All the distribution system, substation systems, everything feeders, everything being monitored by a particular NPDCL. Maybe they are sitting at the somewhere in the Hyderabad like that. So that is how it is happening. Main goals of this distribution automation system is it will reduce the cost, improve the service reliability, and the customer services also being done. And what are the main objectives of this distribution system automation here? That it is the goals here is to do power quality. They try to improve the power quality in terms of voltage and current, the magnitude. Because when you say the power quality, suppose this light or this power is blinking, some kind of flicker is comes, so I can say it is a kind of the quality of the power is poor. And he doesn't want this kind of quality. So to improve that or to avoid this kind of flickerings or voltage sags, voltage swell, or any kind of harmonic which is coming from any non-linear loads when you are going to connect to your power system, all this being try to be mitigated or try to be um, maintained in a good way. That is called the power quality, and this is also being done through the power system automation in terms of distribution automation. Is taking the role into that. Demand side management analysis. Demand side, it is called demand side response. So here, generally, what actually happen here is there is a load curve. We have a load curve, and the main problem will arise in the power system is because if the generation and your demand is not perfectly matched. Suppose the generation is equal to the demand, no problem. 90% or 98% of the problem will be solved because already that whatever generation is coming, you are consuming the same power, so no problem. It's nothing is happening until unless some kind of fault or some kind of abnormalities happen. But what the demand side management system is doing here, they try to defining the load curve for that. Maybe the next day, tomorrow, what could be the load curve or what could be the maximum demand is going to be required for the particular customers. It is going to be known from the ISOs. The ISO is a kind of entity which is acting a mediator between your customers and your generator side. Therefore, when the load is coming, suppose I have my house and I have a smart meter was there in my house and something my residential. And tomorrow, what the energy I need, I will same kind of information I will pass to the ISO that tomorrow I want 24 kilowatt hour energy. That's it. More than that, I won't use it. The same like you also give the same information to the ISO. The person also give the information to that. Finally, all the information will be consolidated by ISO. Then finally, they come to know that tomorrow what is the amount of energy the people they wanted to utilize it. That is known to that generating stations. Then that is easy for them to generate the power. Then it is easy to be ready with the generation. Like that, they try to match the generation and load. That is called the demand response analysis or demand response program. And to make this is a mechanism. This is actually the mechanism how to work. But until unless there is no communication, how should I know? I know that tomorrow I want to use only 24 kilowatt of energy. But to how I have to communicate to that particular generating station, until if I doesn't have any communication, so I can't do it. So I need some kind of information and communication technology in terms of this, then only I can able to do. So this is what the distribution automation is doing by making use of your ICT technologies. Something like optimal operations also in terms of that. Distributed generations, generally DGs are you can call them as renewable energy sources. Why the name is given the distributed generations? Because they have been connecting near to the consumers loads. And or I can say this DG is mostly connected at the distribution levels, where whenever this generation is happening, to let us say the PV, photovoltaic, or wind, these are some of the DGs which will be there. When the power generation is happening, immediately I can supply the same generation to the load, or if chance any excess amount is comes, then only I can try to inject back to the grid. So this is operation is also can be effectively managed by this distribution automation. Along with that, monitoring, controlling your configurations, fault diagnostics, all kind of even the system restoration is also going to be possible. Any abnormalities has comes automatically. This system restoration is also going to be possible into that. So this is about all about the power system automation, and the people try to understand how what is meant by the automation, and what the people doing that one by make use of achieving the different monitoring and controlling, and also to demand side response and other things. It's a SCADA in the power system, and how will you define the SCADA here? SCADA is a terminology generally used when the process to be controlled in a spread over a wider geographical area like the power system. Automation and the SCADA both are same. I can say that the meaning is same. Automation you doing or SCADA, both are same. But the SCADA is the name is given some applications like if the same automation if you are implementing for a larger geographical area, then that is the name is given as a SCADA. Supervisory control and data acquisition. That is the name. That is why automation mostly people they're going to work on automation is the word people they try to use in the some of the industry. Let us say I have a ship automation if you're doing it is a kind of a automation they are doing it. Aircraft, it is a flight automation. You cannot say the sky. Just a power system, it is a high geographical area, it is covered and it is being automated. Therefore, the name I can technically I can give the name is called the SCADA. Like that. What is the definition of the SCADA here? SCADA systems are defined as a collection of equipment that will provide an operator at a remote location with sufficient information and determines the status of the particular equipment or a process, and also it will do action to take the place regarding that equipment or process without being physical present. If you look this definition and look back the definition of the automation, both are the same. Here also we are trying to controlling, managing all the electrical equipment with human interventions. The SCADA and automation both are same, but especially this is what SCADA is going to be the word which is going to be used in this particular case in the power system because it is a covered with a larger geographical area. And there are two implementation activities is done in the case of automation. Is one is the data acquisition of process of equipment. That another one is called supervisory control of the process. The two involvement from that when I I've shown you the layer 1, layer 2, layer 3. From the layer 1, the data is trying to be captured or data measured, and then it is going to the data control center. That is the first step, data acquisition or monitoring process from the equipment. After that, the supervisory control of the process. From the data control center, they are trying to controlling field improvement. This is the major two leading concept or leading steps which is going to be happen in terms of the SCADA implementation. There are steps involvement here. All the SCADA start with the field equipment, and from the field equipment are the equipment which is being monitored. Then some kind of appropriate sensors will be placed on the field equipment, maybe temperature sensors, maybe current sensors, any kind of sensor which is being connected or try to be there in your field equipment, and that is going to be convert the sensors, the signal which is going to be convert in terms of voltage or current signals, which is maybe analog signals. And those analog signals again convert in terms of digital form through kind of ADCs. After the signal has now converted into the ADC, the communication is doing the rest thing. We have a communication lines. Through the communication line, this information will pass into the data control center. The same thing is going to be happen in the reverse process also. That is what it is happening. So this is the steps involved in the SCADA. Data from the field, convert those data into the transmittable form in terms of digital form, something like that. And all this information, the data is going to be convert into in terms of pockets. Pockets are it's called the data pockets. The name has been given that the data pocket, it contains the actual data. Along with the actual data, it is also has some of the other informations where the data has to go and from where the data is coming. When you see the pocket, data pocket, it has actual information. Let us say 2 volt. 2 volt is the information. It is coming from a particular transformer, let us say. And like that, n number of transformers will be there. But how to know this 2 volt is coming from which transformer? That extra information or field is going to be decided by that. So that is called the data pocket. It consists of actual payload as well as the other information. Then this data pocket is transmit through a communication line. Then it is received at the control centers. Then the control center try to decoding the data. Finally, it is displayed in this will go to the screen so that you can able to see in this particular display this transformer value has measured as 2 volt or 230 volt, something like that. It is in abnormal condition, then you are very good. It is abnormal condition, then only you have to take the action. So that is what it is happening from that. Now, this is the complete power system now. This is the complete power system now, and this is where the master station we are sitting here. The master station. This is the complete power system, and this is where the master system is sitting. All the field equipment which is there in the power system, whether it is a distribution system or it is a substation systems or substations or distribution system, field equipment, all the data has been measured through sensors and transducers, then converting into digital forms, then through data link or through the communication channel, it is going right. This is the one way of data formation is happening there, and controlling action is coming like this. From the data control center, anything is happening. Suppose you have a particular bus, some voltage fluctuation was there, and where some kind of loading transformer, trap changing transformer is placed over there, and some voltage fluctuation happening, you just give control command so that this tap changing transformer try to adjust it so that it try to maintain the voltage. So this is what the command is coming from here to controller action to the power system. This complete the SCADA process. What are the different components will be there in the SCADA? What are the different components will be there in the SCADA? The first component here is IEDs, RTUs, IEDs are data concentration. This is comes under the one particular component. Generally, RTUs, remote terminal units, and IEDs are called intelligent electronics devices. Both are the same, but it is advanced one as compared to this one. Some kind of the data control centers will be there. This is actually a diagram which is showing complete SCADA system. Complete SCADA system. It is a field equipment, in number of field equipment which is there. All the information being carried through this IEDs or some RTUs, and this information now passes to the master station here through this particular passes through here to a your master station, something like this. So the information is passing like this, it is going to be happening and this. What is the difference here? Why this RTUs and IEDs has come? Because when you see the role of this RTUs and IEDs in the SCADA system, both are same. There is a IEDs are little advanced as compared to RTUs because this IEDs has more interoperability operations. So that is what it is showing like that. Thereafter that this is one of the component of SCADA. The second component is communication system. This is the communication channel is another component of a SCADA. Third one is the master station. The master station is another SCADA. Sorry, component of your SCADA. The human machine interface, HMI, whatever the HMI interface what we have into this is also going to be one particular component. There are four components into that. Let us see the quickly what is RTU and IEDs, why the people are saying like that. Uh, if I say the a very basic difference between the RTUs and IEDs only they try to monitor and try to measure the information they try to carry out to the information same to the data control center. Whereas IEDs they are intelligent electronic devices. Name itself showing that they're intelligent electronic devices. They're not only doing the data acquisition and control, along with that, IED is also doing the protection purpose. Also doing the protection purpose. So that is the major role which is being created or being taken by your IEDs. And these are some of the roles which is doing by that. The primary functions of the RTU is only data acquisition and remote control can be done. But whereas your IEDs is doing protection, control, automation, and the monitoring. So these are the very, as compared to some of the time, relatively slow or relatively fast, something like that. It is doing that one. And some of these analysis also you can see data processing in terms of protocols also. What type of protocols they try to be compatible with that TNP3 protocol, IEC 60850, 61850, 60870 protocols all going to be there. It is a less intelligent. RTUs are less intelligent and your IEDs has the most intelligent. What is the example for IED? Electrical power system. Let's tell one of the example for IED. PMU, pressure measurement unit is IED. Your smart meter is IED. Smart meters, isn't it? This is one of the RTU structure which is showing here something like this. Typical RTUs in the substation. So whatever this power system automation, what we have today in the traditional substation, where this kind of RTUs are maybe fine. This is the capacity of GE. I'm just showing you inside that many sub blocks will be available like that, and communication subsystem, logic subsystem, termination subsystem, something power supply substations are available into this. After that, again there is advancement has come into the IED. It is called advanced RTU functionalities. The only the difference has comes here is that only draw type card has been come into that. It is the old one, and then after that some advancement is comes, and it is has some kind of draw type card. It can be removed from the RTUs, and then any maintenance work they want to do into this particular RTU doesn't want to connect complete device. Instead of that, this card can be removed and engineers will come, they try to diagnose it and they try to fix it, any kind of errors or any kind of try to inserting back. So that is only the difference here. It has come to that. And come to the flow of data feed from the SCADA control center to two. This is one of the best example how these RTUs are working to monitoring any kind of the work or any kind of the your power system. This is a data transfer from bus bar to the control center to HMIs or data control center. Let us, I want to monitor the bus bar voltage. One bus bar is there. I have to monitoring the bus bar voltage something like this. It is a 220 volt kV, the field equipment. And you know, it is a field equipment. After that, some kind of CTs or PTs or some transducers are required. And we are trying to converting the signal into a very low value or low signal. Maybe converting to that one. So in terms of 110 volt or 4 to 20 milliamperes, converting it. And this is an analog signal. We are trying to convert that analog signal into a digital form where your RTU is sitting, which is near to field equipment. From this digital signal, now we are converting back into digital signal. We are trying to converting back into the data packets. Now these data packets try to be communicating to data control center. So this is the best example how the data flow is happened that to monitor this particular field equipment. Bus bar is a one kind of field equipment can be controlling water. That is this is one about this one. And now come to IED functional diagram because when you see the RTU, it is only simply data acquisition and monitoring. When you say I have to use only, it is has only data acquisition, data taking from that particular field equipment, and then try to monitoring, and also sometimes it also try to controlling. When you see the IEDs, it has many added functionalities in terms of protection. It is also doing the metering. It also do the event recording. Event means that any kind of event, maybe the normal, abnormal condition, it could be an event is happening that is also recorded. Fault recording and some kind of application logics. You can able to do that, and some of the selected protocols also can able to be designed here. Protocols, when you see the comparison with RTUs and IEDs, in some cases, RTUs doesn't compatible with all the protocols. That is why when IEEE people, they are sitting and they try to be come up with some kind of open source protocols that is called DNP3, IEC 60870 or something like that. And when come to the IED, it is a versatile. IED. IED is a versatile something like, and it can be manufactured with any people. Let's say GE is manufactured one IED, ABB Hitachi is manufactured another IED. And if I want to connect this IED and this IED, they can be compatible. Or I can say interoperability operation can be possible because this is where your different protocols can be work successfully in order to data transfer. So that is what it is happening. This is one go. You can able to see what this IED can do. It can do the metering, it can do the monitoring, it can control, it can production. These are the major functionalities it can able to doing this one. These are the some of the photographs of IEDs which is manufactured by General Electric, which is called the relay IEDs. Why I am now calling it is a relay IEDs because in the IEDs itself the protection functionality has been incorporated. IED itself now has a protection functionalities. Previously, when you have studied that the power system protection for electromagnetic type of relays or something you have studied, and they also has each relay has suppose overcurrent relay. It is only dedicated to protect the overcurrent. Under voltage relay, it is only for the under voltage. It is like overcurrent, over voltage, over under voltage, many functionality. Distance relay, it is only for that. Or something field equipment protection that is also going to be for dedicated. But when come to this particular relay, This itself has a multi-functionalities. It can do all sort of productions, over current, over voltage, and under voltage, all sort of functionalities can able to do. Along with that, or along with all the functionality of protection, it is also metering, monitoring, controlling is also there. So that is how it has importance of the IED. That is why if you want to make any subsystem automation, this one IED is sufficient. One IED, one high-speed LAN cable with one a small control center. This is sufficient to make automation. Instead of running a large number of cables, large number of big panels, and all type of things, right? This is the functional diagram inside. When you look into inside of the diagram of IED, this could be has many sub blocks, something like real-time clock, functional programming logics, disturbance, and some kind of self and external circuit monitoring is also it doing. It is also self-diagnosed also. So the IED is not only trying to monitoring the power system. Along with that, it also it will doing that any kind of problem internally it has, it also self-diagnosis is also going to be doing. That is also possible with respect to this. Now we can see these are the many IEDs with different manufacturers. You can see this is one IED, this IED. All are not same. They are manufactured by the different companies, and they have been incorporated into somewhere in the power system. And all these IEDs also you can see all they are compatible with all sort of the protocols here also. You see these IEDs can be also can be able to be compatible with 61850, Modbus, DNP3, or some kind of protocol is also going to be compatible. Now here, irrespective of the protocols now, if you want to communicate this IED with respect to this, they successfully they can able to communicate. This IED and this IED is also going to be communicating. Or this successfully the data can be communicating to here to your substation or master station is also going to be done. So this is how slowly this IED is taking a role into your smart power system. These are the main functionalities is doing by this IEDs. Protection function including phasor estimations, doing programmable logic, breaker controlling, metering and power quality analysis, self-monitoring and external circuit monitoring, event reporting and fault diagnostic. All major functionalities also being done by this IEDs is doing that one into this one. The master station we know master station it is consist of many what do you call the room which is consist of the many servers I can say. Suppose a transmission management system, the transmission management servers will be placed. Distribution management system, DMS management servers are there. And metering, AMIs are there. The smart meters are there related to the AMI servers, management servers. Sometimes when the people are making some kind of transact to energy markets, some kind of energy market they're playing a deregulation or something they're doing, this kind of servers is also playing. A lot of equipment and computers and the servers being placed over there. That is yes. Here it is a combination of hardware and as well as the software components will be there. So software is something like whatever you are running, right? Load flow algorithms, optimal power flow algorithms, economical load dispatch or you are running, or voltage stability algorithms. All these algorithms, something like the software based algorithms, also been incorporated at the master stations. The people doing that. Now, this is a very small master station I'm showing you. This is the best example is that this would be a best example is nothing but it is substation. Substation itself is a small master station. One small console is there here, small console operator. Maybe different field equipments will be there here, something like this. switch gears, transformer something, and one LAN cable is working, and all information is being monitored by this operator console. Then, and all the information further going to the hierarchy. This is only the small, what we call the one substation is now being automated through your IEDs or RTUs with all the communication lines and a small console or small control center. Then this information now passing or try to be moving to the hierarchy through routers. This is one of the best example for the substation automation. This this is called that medium master station. Now, what the information is coming from the hierarchy. This is the information is coming from here, right? It is a information carried from lower hierarchy. That is one of the substation information which is carried through the node. Now it is going to this particular master station. This master station may be located in the Hyderabad, let us see. It is that master station which is located in Hyderabad and one substation which is located in our college. And from here it is automated. The information is passing through the route and it is coming here. Then the information passes to the Hyderabad where some load display center or some kind of data control center is running. Where a lot of servers will be placed like ISRs and ICCP, Internet Control Protocol servers, network management servers, deploy some kind of development servers, all will be there. And some kind of peripheral devices, printers or some kind of IO devices will be to print some kind of reports and all kind of will be available. Now from this center, again the information is passing to hierarchy again. Hierarchy is something like which is sitting at the delay. Now that substation of being automated and itself small data control center was there. One human is there try to controlling. Still this information passes to the regional load somewhere in Hyderabad, and from where all these substations being monitored. Then this information again further carried out to the national level, maybe the national load dispatch center, which is sitting at the Delhi, and where this is the kind of the national load dispatch center. Example, structure of the Power Grid Corporation Limited (PCCI), the large master station, something like it has the redundant two lamps will be connected like this because the most of the times what happened here is due to any kind of failure, any kind LAN is failed, then it should not be there should not be any kind of disturbances or should not be have any kind of disconnectivity into that. It is should be always continuously. It has to be monitor all the complete system in your Indian grid. So therefore, the two redundant LANs will be connected, and where a lot of servers you can see, SCADA servers, NMS servers, and also the TMS transmission mission management servers, DNS servers will be workstation consoles. Along with that, some of the firewalls that is related to security. That when the complete automation through your communication you have done it, so there is a kind of firewalls and some kind of intrusion detection systems and some of the security thing mechanisms, everything will be connected over there, and they try to monitoring from there. This is the department, and this is the kind of department or office section. They always try to monitoring any kind of attack or any kind of malware it is entering into your systems like that. So this is how completely you can able to check try to visualize the system like that. And these are the major applications we are doing it. Everyone knows you are the power system engineers or you are electrical engineering. You are studying your power system 1, power system 2 or some kind of power system 3. You all know that automatic generation we are doing it are economical load dispatch calculations, you know, the operations and programs, interchange transaction schedules, you know, transaction evaluation, you know, how to do the unit commitment also, you know, to schedule some of the generations and short time load forecasting, try to identifying and try to forecasting the load and try to be prepared with that. And thermal and hydrothermal coordination. Even sometimes we have a renewable energies, wind and solar coordination is also another part has come. This mechanism everyone knows, but all this is going to be automated today through your ICT technology. That is what it is doing. This is functionalities doing at the transmission level, where network configuration, state estimation, contingency analysis, three-phase power balance, power flow, optimal power flow. We have all the kind of what you call that loading algorithms or kind of flow charts or some kind of mechanism to analyze all these until you have a data. You want to do the load flow analysis, you require some data, some bus voltage, current, bus angle, this, that, everything you need. You know the information, then you are trying to running the load flow, something like that. You are doing it. So load flow generally it is the static. It is not a what you call the real time manner we are doing it. It is a static or offline manner. Some already existing information are taking it, try to running it, and then we are trying to see it is the voltages of each and every buses. How voltage are kind of followed by the angle, something like we are doing it. State estimation is called the real load flow. State estimation is called the real time load flow, where your phasor measurement units, that is called IEDs, isn't it? IEDs, PMUs are nothing but the IEDs, which is placed at the different buses at different locations in the power system, and from there the direct information is going to be coming at the data control center, where the real-time load flow is going to be performed. Every second, they know what is the voltage, what is the bus voltage, what is the angle, what is the power flow through the line, what is the active power flow through the line, what is the reactive power flow through the line. So everything is going to be done real-time manner. So that is the call that one. In contingency analysis also the people are doing simulating some kind of line outages happen, in how the generator outage is happening, and all this going to be doing all this. So these are the applications we know, and we are doing it in offline manner. The same thing we also can do with the ICT information, with the existing data with the existing data availability. In distribution automation applications, of course, in the distribution, all these functionality we carried out, like fault identification, network reconfiguration, load management, demands response, active or reactive power flow, power factors control, everything we are trying to do. No automation was there. No automation was there. Some fault was happened. So what are you going to do? You have a substation and that transmission is going, one feeder is going to somewhere, and the fault is happened, and suddenly the power is gone. What are you going to do? The man has to check or he try to inspect this line from his substation to, he has to go to that line and completely he has to monitor, and he has to try to identify it, and he come back, then he has to restore the power. So this is the amount much of time it will take. 10-15 years back, like that only, and the cyclones comes, and rain comes, power gone means it's gone. Who doesn't know when the power will come? Maybe 2-3 days after that, again the restoration was happening. But what today? Within no seconds or within half an hour or within maybe in the 15 minutes or 1 hour, the power restoration happening, because they know they able to identify exactly where the fault is happening, fault location or fault happen, the distance where it is happening. So everything is going to be possible, or everything is going to be happening through your ICT information when you are going for the automations, something like that. This is an example I'm just showing you. It is related to your home automation. Home, very small home, you try to see, and it is making a complete automation. This is a display. Maybe you may get in your mobile. If you make automation, you may say that mobile that. Suppose the PV solar generation is also there. Rooftop is there in your the home top. How much power your consumption? Sections you can made also. If you have a home automation means, let's say living room is one zone, Your kitchen is one zone, one bedroom is one zone. Like that, you can make different loads. And how many loads can we turn on and how many loads turn off? Everything is available. Now, you can look this, and by looking that, you can also say at this present time how much power your consumption is going. That is also come to know, and how much generation you are doing through the PV solar. How much amount of power generation you are doing. So let's say the power generation is more here, and that whatever the power consumption is less, no problem. Because whatever the power generation from PV solar, let's try to be consuming here. In some case, this is amount of the power generation is less is coming if that amount of the energy consumption is more means try to taking the energy from the grid. So that time extra amount of tariff you have to pay. So this information you can come to know from this particular automation. Then what we will do? We try to turn off some of the fans, AC somewhere here. We try to manage it so that optimally whatever the PV generation is coming, you can able to utilize it properly without taking the extra energy from the grid side. So this is how the automation is working. The very small example, I'm just showing you the home, how the people are doing it. This is also one of the picture I'm just showing you. Electrical energy management system, the SCADA and the power system. The people who are sitting at the data control center, this kind of HMIs console will be displayed there, and then they try to monitor each and every substations and lines and feeders and under the substation of particular area zone, how much energy they are being consumption, everything will be monitored also. These are the examples of that happening. And this is as a whole the schedule is looking like this. As a whole, the SCADA is looking like substation 1, substation 2, like that n number of substation. Each substation is this is also automated, this is also automated. Information is taking all the data will be carried to the main data control center through a communication line, which is maybe a cable or wire or wireless. This is called a SCADA. And therefore, when the data communication is happening from here, when you see, when you have done the automation here, the substation 1, substation 2, something like that, when this data has to go to the data control center, or I can say when the your power system data has to be properly communication is going to be happening. Therefore, the prime element or the core element is the communication system. So without communication system, there is no automation. Without communication system, there is no smart grid. So therefore, the communication system is taking a vital role in case of the power system. So the communication system plays a vital role in the SCADA implementation, especially with many time critical application in the power system. The communication media and the protocols used in the power system require the special treatment. The communication system is not a new technology, which has been there. Your mobiles, different people, they are using it, communications and all. And the same kind of technology I cannot use in case of your power system because it requires a special treatment for that. Why? Suppose when you are talking with mobile with some other your friend, sometimes your voice is breaking. Some kind of signal loss or something is happened, but you try to manage what he's trying to communicating to you, right? Sometimes he's saying something and some kind of in between few seconds some voice is lost. It means that you might try to understanding that oh, something is telling means you are able to understand what he means. But the same signal if I send through in case of our system, let us say 2 volts or 3 volts, 230 volt is coming from one particular generation or 230 volt is coming from one particular DC, and instead of there is no proper communication due to some kind of disturbance in here, it is reached to 31, 235, something like that. We try to shows that your power system is in mal-operation, something like that. Right? Let's say the frequency 50 hertz. What is the tolerance? Plus or minus 5 percentage. I can say 49.5 or 50.5. Within that tolerable range, I can able to operate my power system. That range I know. because of some miscommunication or due to not the proper communication technology has been developed, it maybe shows more than that. Let's say 51 hertz. Then what will it show? When it is showing the 51 hertz, unless you are trying to disconnect your system. So this is a kind of the issues will be there in terms of the communication. Therefore, when you are implementing this kind of communication system, it requires a special treatment. So that is very, very important into this. Now move on to the communication. We'll see a few things how this communications is adapted into your the smart grid here. Elements of the communication generally, this is the source, one source, and this is another source. Let us say it is a data control center. It is a data control center, and this is IED. It is a IED, and in order to communicate this IED from here to here, this is where you can say the communication network. This is what they were communication network, and the major elements in the communication network is node and links. The major elements in your communication links are node and link. Best example for the node, best example for node, node can be your switches, hubs, routers. Routers can be a your node, something like that. This is a link is nothing but it can be a cable. It is maybe a wire or wireless can be possible, and some of this is. So this is in case of communication network, the power system, the basic elements of communication is called the node and the link. So this is how the nodes are working. This is how the nodes are working to communicate with each other. This is the people who are working or they are working with a different application. Somebody is withdrawing the money, somebody is talking with their phone, somebody is emailing to somebody, and people are doing like this. And they are all are interconnected to this particular node here, something like that. So there is some kind of uh, characteristics of the node. Node has only the limited capacity. It doesn't have a much memory. Whatever the information is coming from source side or one particular end, this information can be carried for a little time, very while. And after that, immediately it will transfer to the second node. And then again it will transfer like this. It will try to communicating to. So I can say that this node stores the data for a period of time and it can transfer the data to the other nodes at the end point. Node has only a limited capacity to store the data. So that is node is doing that one. Now come to the link, the communication links here. This can be wire or wireless. If I go with the wire, maybe copper wire, fiber optical fiber can be, they have the wire type. Wireless, mostly people are going with the radio waves or through some kind of the airs also. And the link can be wire or wireless. It may be divided into different channels again. Maybe how? Let us say one high speed LAN was there. Previously, I told you one high speed LAN was there. It is going from one console or one data control center to your substation. And this high speed LAN is not only connected to one field equipment, it will be connected to the many field equipment. It means that that LAN itself has some sub channels inside that particular LAN, sub channels into that. So therefore, each sub channel can be considered as a link. So that is what it is showing that. Therefore, sometimes sub channel again divided into again the sub channels, and all can be considered as a link also. Next example is televisions. In the televisions, only single LAN is coming, right? Somewhere one dish TV, the dish cable is coming to your TV and it is connected. Under this single cable, you are getting more than 500 channels, right? It means each channel has its own dedicated link going inside that particular cable. So that is why I'm saying that each cable has different sub channels, and each sub channel also can be considered as a one link. So that is what it is showing, something like that. That. So after that, there is another concept, it is called connection oriented services and connectionless services. Connection oriented services and connection, this is also going to be playing a vital or very crucial role in the case of your smart electric grid here. The connection oriented services, what actually doing here is, in the case of connection oriented services, let us say this person has to communicate to this person. It is a communication line or communication network. It has, which has many routers. Routers are nodes, and links will be connected under the connection oriented services. When these two people want to connect or these two people want to communicate with each other, there is a predefined path has been defined every time. Every time when these two people are two data control center and IED, so let us say IED and IED want to interact with each other, there is a dedicated path is going to be predefined. Every time when they both has to communicating means always this is the path they prefer to. There are many possibilities. This can go like this also, right? This can go like this also, it can communicate, or like this also it can communicate. So many possibilities are there, but before that when these two devices has to communicating, there is a dedicated predefined path will be defined into the system. That is called the connection oriented services. Connection oriented services. The next one is, there is no leakage into this because already predefined path is there. Whatever the data is coming, the stream of data will always follows and it will goes to this one. Next one is connectionless services. In the connectionless services, there is no dedicated path. There is no dedicated path. But here, there is no dedicated path. Therefore, maybe this time when these two devices are interacting with each other, this path is going to be taken. Next time again, these two devices want to interact with each other. This path is going to be taken. The next time, maybe this path is going to be taken like this. It's like this it is taken. So anytime, any direction can take, but finally it is reaches to that particular destination. That is called a connectionless services. But the problem with the connectionless services is that if only the two devices is there, no problem. Two devices are there, or two IDs are there, no problem. Let us say another IED is there here. Do you have any write up pen for this? Let us say, do you have any another IED is connected to here like this? Only two IEDs are there, no problem for this. Suppose here another IED is there.
మధ్యలో నాకు వాళ్ళు వస్తున్నాను
Okay, this one.
ఇది వాటిలో
So in case of connectionless services, because only the two, there is no problem. Unless they can communicate any route, they can do it. Let us say another IED is there here. It is connected from here. Here it is another connected there. There is a problem because when data is coming from here, only it has to extract this particular person means that exactly the data has to go there. Should not be go to some other place. How this problem is going to be solved in the case of connectionless services is called the data address. Now, previously in the connection oriented services, simply only whatever the actual data is there, it is gone to source to the destination. Now, in the connectionless services, because here there is no dedicated path, every time the data can go from any directions. It can go from the any room also. So, which is the problem. So, how identify from where it has come and where it has going is called the address. We are trying to make some kind of address. We try to provide address for the that particular data. Now, your data, actual data, with some other information is going to be called as a data protocol data units. Or sometimes it is also called as a data packet. Now we understood the data packet has comes, which is nothing but it has actual information. Other information maybe IP addresses, MAC addresses, all going to be information going to be carried out. So this is called data pocket. This is how solved by the connectionless services into that. Now tell me, you want to go with the connection oriented service or connectionless services in the power system? Okay, read this point, then you come to know which one you want to go, connection oriented or connectionless service. First we see the connection is, it is prior to the connection need to be established, no prior connection is required. Okay, that's fine. Resource allocation, resource need to be allocated because when you are making a connection means it is predefined. This router, this router, this router, this IED has to be connected. This kind of resource we are allocating. Whereas there is no such thing will be there. Reliability, it ensures the reliable transferring of the data. More reliable. But whereas reliability is not guaranteed, it is first effort services. Even though it is a fast and very effort services, no guarantee of the reliability. The data is not going to be happening. And the data transmission is also, the data packets will also going in terms of sequential manner. When the data is there 10001, the same order it will follow to the destination point. Whereas in the connection less services, the data go in any random manner, but finally when reaches to the destination point only, they try to rearranging it. There is a possibility that there is a data loss. Delay, there is more delay, there is no delay. Suitability, it is suitable for the long and steady communication. It is suitable for the bursty transmission lines. Now tell me which connection oriented service or connectionless service is most suitable for power system. Connection oriented is the best suitable because there is a data loss should be there. Because it doesn't need any data has to loss. Something is lost means definitely you know it is a 230 volt is coming. It is in terms of bits 10010 something it is happening because of data loss. One digit is missed. It may lead to some 440 volts something like that. It should not be like that. And this is what connectionless or connection oriented services is happening. And there is another model. It is called OSI reference model. Generally, uh, when the two computers, let us say the two computers want to successfully communicating to each other, communicating to the each other, and let us say this computer is operating system is something like a Microsoft Windows, and this computer is operating with some kind of Mac operating systems. And in order to communicate these to each other successfully, there is a one kind of inference system has been defined in 1984. It is called OSI reference model. In order to do that, because this is also one of the important aspect in your power system, because when you see IEDs, some of the IEDs which is going to be manufactured by GE, some of the IEDs which is manufactured by ABB, some of the IEDs manufactured by some other companies, and all together now we are trying to be connecting each other. We're doing that one. So same thing is going to be going here. In order, in order to communicate the systems very successfully, in 1984 there is one kind of inference model has been developed. It is called OSI inference model here, and it has 7 layers. It has the 7 layers: application layer, presentation layer, session layer, transportation layer, network layer, data link layer, and physical layer, something like that. Suppose Suppose if I give some kind of information here, application layer, from that the information will process to the presentation layer. This presentation layer where actually the information is going to be tried to be convert into a digital form, convert into a digital form, and some kind of encryption process is also going to be happen. The data will pass us to the session layer. The session layer, it is to establish the connection between the two hosts, maybe between the two IEDs or two computers, IED to data control center like that. After that, again the data will transfer to the transportation layer. Here the transportation layer, it is try to do the data flow control and data error check. That kind of functionality is being done in this particular layer. Data will transfer to the network layer. Here the logical addressing is going to be done. Logical addressing like IP address, IPv4, IPv6, like that. We're trying to convert it, the data into IP address. No, it is combination of IP address with the data is going to be in the pocket. After the same data will goes to a data link layer where MAC address is going to be decided. MAC address of 1, MAC address of 2. We further it is decided. Then the information will try to be convert in terms of signals, and that signal will pass us through some kind of physical medium. Physical medium may be a cable, or it is maybe a wire or wireless. Like this, data felicitating from application layer, presentation layer, session layer to the physical layer. This is what exactly it is happening into this. So if I say this is one IEDR data control center here, something like this. This is one of data control center. And IED is there. They have both want to communicate it. Let us say 230 volt is the 230 volt information has come. That data will be facilitating to all these layers through. Then it will go through this particular physical medium or wire or wireless, and finally it reaches to this particular IEDR data control center where whatever this measure element measure value is going to be displayed over there. So this is that when you see in the smart grid with the ICT information inside this kind of reference model is working and how the data facilitating is happening. This is an example you can see. SCADA master station at the data control center to IED or RTU at the substation. How these two are interacting? Through this particular physical medium, maybe wire or wireless, whatever it is here there. But this is where the different layers, it is called OSI reference models, has been decided here to communicate with each other. So that is how internally it is happening between that. This is another example of showing that. Okay. So till now, only given only the scratch, very basic information about the power system automation, then the SCADA, then after that, just little bit communication to understand it. Now we'll move to the smart. Now you have to understand what is meant by the smart grid now. The smart grid, it is a now definition. How will you define it? There are the 4 R's. How will you define the smart grid is? 4R. It is a resilient, reliable, robust, and reconfigurable. When you are designing it, now you know that. What is meant by smart grid means inside RTUs are there, IEDs is there, smart grid communications is there, data pockets will be there. Isn't it? Some kind of OSI reference model is working, protocols are working, isn't it? And whatnot, information technology, some kind of consoles, master stations, everything is working. You have got that idea, right? Now the smart grid is, it is a 4R. It is a resilient. See, this four line, the 4 words I have defined it. This is defined by this person. Smart grid is a resilient. It must be a resilient. It must be a reliable. Must be a robust. Must be a reconfigurable. 4R I'm just giving. What is meant by smart grid means 4R, not triple R, right? Then James Momoy says that smart grid is an advanced wants a power system network having two-way distinct as well as electrical power flow, capable of self-healing and adaptive, resilient and sustainable, with foresight for prediction under the different uncertainties. It's equipped with interoperability with present and future standards of the component devices systems that are cyber secure against all the malicious attacks. Everything is included in this definition. When he defining the smart retailer, it should be a two-way communication. That system should be very advanced. Any new technologies also comes, it has to be adopted into that, and it should be very robust to any kind of cyber security. Okay, the devices, whatever the IEDs are used when you are using, they must be interoperability operations. Every data has been given by that. And there is another definition is given by National Institute of Standard and Technology, NIST. It is in USA, has also defined it. A modernized grid that enables the bidirectional flow of energy and uses two-way communication and control capabilities that will lead to an array of new functionalities and applications. That is main motto of smart grid. Without human intervention, you have to control your power system, monitoring and measurement and protection of your power system. This one. You're not unable to understand these topics like that. Yeah, you don't know. That's what I'm saying now. You are the electrical engineers. When you are saying the smart grid, communication will interest. In the communication enters, I'm just giving you a little bit about the what communication is doing it. When you are going for the job, you doesn't have any role in the communications. Communication people are there, they will design it. Your role is you have to sit in the direction of the console. You have to monitor what is the voltage, what is the current, what is happening over there. Also, you have to design your own algorithms. Communication is not a role of you. This is one of the best example which has been happening in the IIT Kanpur. Kanpur government has sanctioned one smart grid project because we have to move toward the smart grid. They have sanctioned it. It is almost 200 crores smart grid project for IIT Kanpur, and they take over in the two villages. They have taken adopted the two villages to make a smart grid. They have put, with some PV solar, wind, some batteries, everything they are interconnected. Nothing. How to install the PV solar, wind and this, how much capacity I need, what is the load demand, everything I know. So this ability they people they have done it. Then one data control center from that village to one data control center. They have been kept, they try to be established, design the IP. After that, they are done. After that, how to interact or how to monitor those the microgrid which is established in that particular village to there is comes that communication loss. But this professor doesn't know about the communication and what type of communication we have to adopt in other things. And they are approaching to the third party. Those people who are the masters or expertise in the communications will brought them and we are asking them to what our requirement. We are telling to them this is our requirement. We have to monitor all these things. This is the amount of data we daily we have to monitor. What is the capacity of the lines or something? What type of network we have to adopt? They are given their requirement. After that, this communication people have been established. Okay. As a electrical engineering, there is no role for you in the communication. At least you know to understand that how this data is working and how controlling is happening in terms of communications. Okay. Uh, then IEEE standard is saying that the very simple definition is given. The smart grid is a large system of systems where each function domain consists of three layers, four of energy layers, the communication layers in IT. It means that it is a one is power and energy layer, communication layer, and 80 layers. So if the three is there, then I can say it is a smart grid with conventional generation, communication, and ICT. That is what is defined by scientific people. They have done it. Now these are the main difference between conventional grid and smart grid. If I go with the smart grid, I make use of ICT. What difference you can make it? What difference you can make it in terms of, you can see here, the structure is in terms of the smart grid and your what do you call this conventional grid, it is a hierarchy, vertical structure. When I go to the conventional one, it is a vertical structure, but when come to this is a distributed structure now, because the two-way power flow is possible. We'll show the diagram how the two-way power flow is possible here. It is happening, it is a distributed structure we have. No participation uninformed here. There is no communication, no information. How much power generation you doesn't know. How much power you consumption, those people doesn't know. This is one disadvantage. Information is there, so communication and the customers are participating here. And in terms of power quality, poor power quality. But you can try to make a good power quality, and power quality is given a priority to that in terms of that. And then asset management, assist optimization, for here you can do the asset management very perfectly. You want to monitor transformer, you can very perfectly you can monitor, because you can do the, from sitting here you can able to see what is the health condition of that particular transformer. All management can be doing that one. Self healing, no self healing. Self healing can be automatically doing that one. So it is going to be done in terms of that, and many others comparisons also there. It is more vulnerable to cyber attacks. Any kind of attack is come. I can say it's a weak grid. Conventional grids are weak grids, and whereas it may be more resilient compared to making user using that one. Disaster management, slow and react, very slow reactive responses come, very proactive response is going to be happen. Any kind of disaster management has comes. Communication, mostly one-way communication is there in here. It is integrated with the two-way communication is possible. Here, event analysis, very smart analysis you can do. If the data is there, data has comes to us, then we have that we can use some kind of machine learning or AI applications. We can able to try to do the data management and all things. Intelligence limited. Mostly it is a very high intelligence is going to be very progressive. Efficiency is poor efficiency is comes, and efficiency is focused here. More focus is going to be given on the smart grid here. And these are some of the best topologies we are using it in terms of that and all kind of things. The same is not required for you. This is also the something like communication topologies. You can say how the information are how these different power system connection has been done. This is the best example I'm showing you. It's called this. Now you can see the topologies how it is connected. It started house area network. It is now it is completely smart meter automated. So a smart meter. This is a smart meter. Now it is a become a your what do you call the router? One of the router like this. This one house, another house like this, and number of house. They are connecting together. It is going to be farming called a neighbor area network, or sometimes it is called a field area network. House area network, field area network. After this, again one more routers will be here. Here something like this. This is going to be connected something like here, and like this. All together is going to be called as a wide area network. Finally, the data control center is working on that. This is the complete vision of your smart grid through ICT information technology. And there is a classification in what data rate, what distance, how it will define whether it is a house area network, it is a neighborhood area network or wide area network. This is something like this. It is given this. This is the classification based on the data rate. Suppose 1 to 100 meters, it is called your house area network or building area network. Mostly here Zigbee technology, Wi-Fi technologies, in kind of technology is going to be a wireless communication. People try to use to make automate their loads over there, right? And this is the field area neighborhood area network. It is 100 to 10 kilometers distance can be considered as this one. And this is wide area network up to 100 kilometers of distance. This is what it is showing here. This is what it is showing here. It is like this, and then finally it is returned to the smart grid, something like that. Okay. And this is now we can see it is a wide area network with connecting together with all the informations in terms of perspective. You can see with AMIs are connected. AMIs is automatic meter infrastructures, like this is smart meters. You have number of smart meters, one substation with one router, cluster routers, another substation here. Like this, some of the distribution generations, electrical charging stations, in these is PV and PV farms, solar farms, individually connected. All together, substations, distribution, these is everything together connected through this is a called a wide area network. This is a wide area network. And then we have a data control center. Now we can visualize that here that house sitting over there, he can able to communicate to data control center from there. So this is the different path he can go and flow and they can able to do like this. It is doing into that particular direction. So this is called a one of the structure. It is a wide area network. So like this, the many topologies are possible. Many topologies are possible. This is what I am shown. The ring topology, which is shown in the this particular uh, uh, wide area network, ring topology. Right? The best example for bus topology is the substation. This is the bus topology. Best example is substation. One LAN cable with one data control center and some switch gears, IDs are used like that. So there are different existing like this. We have topologies also, and then this is what it is happening. The communication, the complete one. This is how your complete all putting together is going to be looking like this. There are some wide area routers and some of the cluster routers also there. These are called the cluster routers. Some cluster routers will be there and some wide area routers will be there. Generally, the cluster routers, CR is called, they are using to in order to aggregate that traffic, data traffic, or in order to try to divert the data traffic. These people they try to use cluster routers. That is the role of the cluster routers in the smart grid. The people do it because imagine millions of smart meters, and every 15 minutes your smart meter is communicating the data, and many PMUs are there. In every 60 seconds per sample, something like data is going to be read by even PMUs. They're doing it. So much of data is going from here to there. All the data is going from here to there. Sometimes this substation interacting with this one, this was with this one. So much of data traffic will be there. In order to aggregate the data traffic, cluster routers will be placed over there. Okay. Sometimes internal routers are also there. Maybe IR routers are called in between here, somewhere. In order to prefer a very short path. Let us so this want to communicate to this particular substation. Maybe this has to go like this, like this, like this, like this, and it has to go somewhere. It's taking so much of distance from here to here to communicate. So that time what they do, interior routers are called here they will keep it so that when it will go to this particular router, inside it can go. Something like your Hyderabad traffic. You have a ORR, this is ORR, right? And all villages are connecting together. And sometimes you want to go with the shortest path. Maybe we will take somewhere from inside. From when you go from this exit point, and then you will go inside and again reach us to that. So that is how the same thing is happening in the smart grid also. These are the advantages power system smart grid. Of course, when you go with the power system smart grid, increase the reliability, lower operating cost, faster restoration if possible, better and active reactive power management we are doing it, reduce maintenance cost, reduce the human influence, errors, mostly errors can be reduced, faster decision making can be done because we are operating when the machine is operating, some kind of event has happened, you will think twice before taking the decision. The machine won't think automatically. Whatever the predefined logic, it will try to operate, it try to implement it, and you try to do that. Optimization problems, it is doing like that. And some of the disadvantage that I cannot say, maybe when the technology is improving, there is a negative way also some kind of impact will be there in terms of some other direction we can say. It is one is that security threats. Security threats is cyber attacks. People are now facing right. So many people are sitting over there. No, the power system is completely automated. Then from the people who are sitting at the China, they try to inject some kind of mal operation into your power grids. Or some people are sitting at the Bangladesh or Pakistan. They try to disturb your power system. Something they're doing it. Security threats are there. Of course, development cost will come because of this technology day by day is increasing. Now with the 2G, 4G, 5G, 6G, 7G, up to we will go 20G, right? 100G also. So and this is also increasing some kind of unpredictable cost. Every time high initial cost. When you are establishing this particular technology, the cost is more, but later again the cost may be get reduced. One paradox here is the people are saying that if I go with the smart grid or suppose automation as the SCADA, most of the people are saying that I try to minimize, I try to decrease the number of humans resources. I try to decrease the cost which is involved with the humans or resources, something like that. Paradox here is the paradox of automation says that more sophisticated the automation power system, the more crucial is the human contribution. Automation makes less human involvement, but their involvement is more crucial. It is more crucial because when you want to go with the very more sophisticated power system, means that maybe with lesser people, even you hire one people or one staff, you should be a more high skilled person. Thing like that. It is one of the best example is given something like that. A fatal example for Air France flight. It is a 447. The flight was. It is a fully automated flight. It is a fully automated flight because there is no human involvement. No pilot is required. When it is start means automatic it will take off. It will reach us to destination. It will going to be landing and all kind of things can be possible. But some few crew are there inside. And the one or two pilots are sitting, but they doesn't know much about that flight. Something like that. So not much skilled persons are sitting over there. And in that case, something is happened to that. Some kind of abnormality or some kind of uncertainty happened to that flight. Now it is entered into the manual mode. Something is happened, but it is fully automated. But because of some reason, it is entered into the manual mode. There is a no knowledge, or no skills of the crew people who are there. This flight is appeared into the sky, disappeared from the sky. So this is one of the example. That is why when your technology is inbuilt, you also has to be more crucial or more skilled with respect to that particular technology. Now move on to the smart grid network. So much is there. Almost 2 hours. Now move on to the smart grid technology because I already told you that when the people are evolving the traditional grid to a the smart grid, this could be the your smart grid now. It is not a vertical structure now. A smart grid is not a vertical structure. It is a distributed structure. Now it is a distributed structure with two-way communication and two-way power flow is also possible. You can see the two-way communication is happening here, 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 something like that. It is now distributed with the different loads. Commercial, residential, industry loads are going to be there here, all going to be connected. And where the two-way power flow is also possible. Example is microgrid. The microgrid itself is a combination of your renewable energy sources and whatever the amount of energy which being generated, it is not only taken by that particular microgrid, it also excess amount is that it is giving back or it is giving back, injecting into grid also. Two-way power flow is happening. Next example is, let us say your Ardhaman college, the rooftop your solar is there, right? Solar is there. They are utilizing the solar power for here. Excess amount is they injecting back into the grid. So don't get it. Sometimes solar is not available. They try taking the power from the grid. So this is a bi-directional way the power flow is happening here. This is electrical to grid to vehicle is also possible in terms of when you have the electrical vehicles is there. Sometimes you may charge the electrical vehicles, no power, same electrical power you can call the electrical power back to way power will power. This is what is looking is called the smart grid, which has intelligent ICT network. Information communication technology is going to be there. So in this, the major role which is being taken by your renewable energy sources, because the day by day this is growing, the demand is growing, and the generation is also has to be installed. Therefore, the day by day it is going, and there is only one option we have is called the renewable energy sources. Now the load increases, what you have to do? Ultimately, have to install one more PV solar or renewable energy sources here. Again, load increases, again I have to do here. Somewhere I have to adjust somewhere here something. And I try to demand that and try to do this kind of things over there. So that is why renewable energy sources is coming here. Why people are looking for the because present fuels is going and also with the resources going to be limited due to some kind of environmental effects or due to some stringent environmental effects or some kind of global warming effects, something like which is showing here, where people are not encouraging to go with this particular fossil fuels. And some people also arguing that instead of renewable energy sources, I can go with the nuclear energy also. Of course, nuclear energy also can be one of the alternative energy in order to make to meet the ever rising energy need. But the many part the world is arguing because it has some negative impact on that. One of the case what happened here it is the Fukushima disaster 2011 in Japan. That is a nuclear plant. Some kind of disaster has happened, and this is actually what the world has been and the little bit impact is also has been there in the India as well that time. So people are government is said that no one coming from the house, everyone stay inside the house. So that kind of guidelines has came that 2011 somewhere. And this is one of the pick just collected from the internet. It is a Kudakulam nuclear plant in India. India is also people are struggling. They are kind of fighting to not to construct any kind of nuclear energy or nuclear things to that. Then how we are trying to meet the energy and demand which is going to be increased in the near future. Therefore, the other alternative energy source we have is wind and the solar. Wind and solar is going to be other alternative energies we have with respect to that in order to make or try to adjust into this particular smart grid here. And they also has this is what the predictions is happening like going the wind and solar by day. Almost we are at the 2024. This is that the far older one. So 2024 it is almost 1400 gigawatt. Wind is has been reaches to the 1400 gigawatt and still installation of that this is also going to be happening with respect to that is and this is the total global install and expectations day by day you can see. Every year, almost wind is 5% of generation is increasing. Solar is also around 7 to 8% of the installation you are increasing is doing this one. This is the grid Indian grid power. The statistics as of June 2024 have collected. This is the Indian statistics showing. You can see the renewable energy sources almost 114 gigawatt we are connected. We are trying to doing this, and thermal is this. Among this renewable, solar contribution is this, and the wind is contribution is this. So you can imagine how wind and solar is contributing more and more in the not in the world, in India is also. This is what it is happening. Almost 80% is increasing from 2014 to when you come to that particular day. And this is almost 46.5 gigawatt of power is generating from wind, and more than 60 gigawatt we are generating from the solar energy. This is the expectations in the near future. So near future, we are trying to expecting from this particular renewable energy sources here something to meet the demands of something like mostly the northern grid, northeast grid, and eastern region. We are trying to be expecting that solar power generations in order to meet or in order to the future near future loads. And southern grid and western grid mostly will go with these wind power generations. Almost this is the amount of capacity is available still. 521 gigawatt is available, 465 gigawatt is available here, almost 339 gigawatt like that we have available. Today, our Indian installed capacity I think around 500 gigawatt. Installed capacity is 500 gigawatt, and the maximum demand now successfully met is 247 gigawatt. It means that we are surplus energy state, surplus energy state, and still we are again looking for the different resources from where we can try to extract the energy. That is especially solar and the wind. That is that information is following, and we are also mostly responsible for the CO2 emission. We are the third largest country doing this one, and we are the responsibility to neutralize or to provide the net zero emission of this particular region also. That is what is doing this one. And this is some of the statistics of Indian scenario. Grids, renewable energy sources is happening. And of course, the Badlapur is the solar power plant. Badlapur Solar Power Plant is the world's largest power station, which is located in the Rajasthan with almost 225 megawatt of power we are generating. In fact, it is the most largest in the Asia, largest Asian solar plant, which is located in the Rajasthan. And this is the largest wind farm, Upandam wind farm, which is located in the Tamil Nadu. In terms of solar, we are standing at the fifth position in the world. In terms of wind, we are standing at the fourth position. China, US, Germany, fourth is India. So that is, we can say proudly say that in terms of renewable energy sources, we are the top five country in the world. That is what it is happening. These are some of the solutions. Recent trends is happening in solutions. This is not only the trends, I can say, this is also is one of the part in the your smart grid. Electrical to vehicle, vehicle to electrical, rooftop, bi-directional power flow, everything is going to be happening into this. And this is that what's happening. So this is another new trend has come into the solar again. Another new trend is also coming to the solar. It is called the agrivoltaics. Agrivoltaics are solar farming. Now people are started because they try to optimizing or they try to efficiently improving their solar their crops as well as they try to be installing this kind of what do you call it, the resources, and they are getting the two-way income from the solar farms, right? They're doing this is a crops with crop production, animal husbandry, people are doing it, ecosystems, greenhouse solars, elevated rain reinforcement, all type of technologies is doing that. Because every type of these technology is going to be coming under the your smart grid in the coming future. This is what the different countries is doing now with the agrivoltaics, something like that. Bangladesh, China, France, Italy. In India is also people are doing that. I think in the Gujarat, one of the person has installed the 2 megawatt of solar plant by taking the subsidy from that government of India, and every month he earning more than 60 lakh profit from that. So that is that how people are doing it. India, Netherlands, all this is going to be agrivoltaics is happening over there, and this is some of the components that government is trying to be involving. People are giving us to do the agricultural solutions like that. Almost grid connected solar plants has been given target to by India under the PM mission. Component B, half solar power plants, agricultural. If you want to go with the, some people are there, the farmers, they doesn't have that last mile connectivity. But if you want to go with the solar fit water pumping system, under this PM cushion you can apply it. Almost this is the amount that has been sanctioned, and this is what actually installed. So still we have the provision to apply for that, and almost 90% of the subsidies we are getting from this. It's like that, and the component C is grid connected pumps, solar pumps. Then we also have solarization feeders, wind farms, as solar farms can be you can install. If you have 1 acre or 2 acres of land, it's a offer to the PM Kusum, but that land should be near to the 3 kilometer or 5 kilometer distance from the substation. And then you can apply it. 90% of the subsidy they will do. They come and install it. Then after that, income will come to you. So these are the some of the schemes we are using it, something like that. So after this, there are many impact in the renewable energy sources is coming. Whether it is going to be whether it is solar or a wind, it is. If it is, I can say that solar. If it is a solar, it is a stationary or it is a static energy conversion technology. It is a static energy conversion technology means that it doesn't have any rotating element. When you study the power system stability, when you study the power system stability, how will you define synchronism or power system stability? Because depending upon the your synchronous machine inertia, some disturbance has come. So because of the inertia of your synchronous machine, it try to coming back to its stable value. It has some inertia, so it will storing some energy, so that it will try to adjusting it back, coming recovering back, it is coming like that. But when come to this solar, it is a static, no rotating parts. This is creating a some kind of stability effect into that. So static energy conversion technology, no inertia effect is there. Another disadvantage is that it has the many components. It is associated with the some kind of power electronics component. When you look the PV solar, if you look the PV solar, then it has only the kind of power electronic devices like DC-DC converter, DC to AC. For converting, generally when you have the PV, DC generation is happening, but try to converting DC to AC. These are some of the conversion is going to be happening. So like many issues is going to be coming like this, and after that, these are the main problems is going to be associated with that. These are the main problems which is associated with that intermittent and variable. Whether it is solar or it is a wind or anything, it is intermittent in nature or intermittent in variable. We doesn't know that when this source is available. Another one is grid stability and reliability. This is a static element or static energy conversion technology. It itself is creating a stability problem. Grid code requirement and compliances. They are also creating a new kind of challenges to the power system grid code operators. Because when you are connecting this new channel to new resources to your power system. And some of the solutions is also given like this. It's there, and this is where the wind is also doing. And under the wind, these are the main problems going to be covered. Under the wind case, wind force generation, power frequency, voltage fluctuations, wind speed variation is happening. Transient stability is also going to be one case. And grid flow requirement is also another case. And some of the solutions are given like this. Uh, these are some of the solutions has been given like this in terms of this yeah. When you have that voltage stability, frequency stability, transient stability, and small signal stability, so some of the challenges can be overcome. Can be overcome if you appropriately consider some kind of track devices, energy storage elements, power system stabilizers, automatic voltage regulators. Whether it is a PV solar or whether it is a wind or whatever it is, these are the some of the considerable techniques or compensation techniques. If you appropriately design them, if you appropriately design them, they try to solve the problem which is being created by your renewable energy sources, which are the intermittent nature. So that is what it is doing. And the many people are working on the different control designs. The many people are working on the different control designs, something like that. It is a challenging task for the people when these people are working the control designs here. Effective control designs is required for to do design this. This is a challenging task for the people. And many people are doing it and is going PID controller, planning mode controllers, people are working, HUC controller, H infinity controller people are working, and also predictive controllers working, then adaptive, optimal controller, predictive controllers, people are working, artificial intelligence also. And I cannot deny that. So some people are says that when you read the researchers, some people say that when the people are designing the predictive controllers, that control is better than all other controllers. They prove it. And another person, when they do the research, they say that my sliding mode control is better than all the intelligent controllers and all the conventional controllers. And some people are working with artificial intelligent controller. They will tell that okay, this control is better than the rest of the controllers. And it is happening that we cannot say that this control will be only the best as compared to that. There is no such universal statement for that. And these controls will be appropriately chosen for a particular application so that this control will perform better way. So that is only the way the people are trying to be doing it. One of the best example is that if the people want to work in the renewable energy sources side, but these renewable energy sources are high uncertain and high non-linearity they have. In order to design their control very effectively, artificial intelligence is the very best controlling mechanism or best control design to attempt any kind of the problem which is coming from that. Under this artificial neural network, artificial AIs, neural networks and the fuzzy logic control are the best major controlling options we have. But neural networks require more data for the train. I have to generate more number of data to train it, and it is more complex as compared to these controllers also. And why this fuzzy logic controllers has gaining more importance than this particular artificial neural networks here is because it is good at the reference track. Any if you give some kind of reference tracking to this particular fuzzy logic controller, it will perfectly track that particular reference. So that reference you tracking perfectly means that the controller is working very nice or very superior as compared to the other controllers. So that is why the most of the peoples are doing this kind of working on that one. And we have designed one particular what do you call this case for that. I will show you this one. You can see the importance of that. This is not necessary for you. This is one case has considered, and under this case, so this is what you have taken the configuration. Which is a wind has been considered in order to design the artificial intelligence for that. Mostly the rotor side converter has been considered. It has torque control. voltage controllers were considered here. This star controller voltage control has been considered. This is where actually when you go inside the star control scheme, it has something the block diagram where this is one control is working. And the textbook from that we have borrowed this data or idea. And this is a PI controller they are using it. The same like voltage control was there. The voltage controller is also it is there. This is the controller is working on. These two controllers are very effectively designed by the artificial intelligence controller. Very effective. Let us say you adopt the methodology and try to design your artificial control intelligent controller such a way that then these are the some of the replacement has been done with respect to this controller, something like this. The same block diagram, you replace here something like this, and just try to frame some of the rules for that. Some kind of fuzzy rules to all these. So try to do that, and kind of tuning rules you try to design it. Then try to see some of the cases, identify some cases with respect to whether it is a flow rated above its synchronous speed or subsynchronous speed, like that. Three different cases with fault condition and voltage sag condition. Then it comes to that. These are the results has been shown with the different cases. You can see that red one is with the controller showing the best performance as compared to the old one or traditional one in terms of that. You can see this one, this one. This is the three-phase parts, and then it is also kind of sudden voltage drop for 50% is happening. Then this is also happen. Then you can see the how the oscillation has been damping with respect to this particular controller. AI controller is doing this one, something like that. This one is also. So all these, well, this is one case. I'm just showing to you to understand that. Therefore, this is one role I'm just showing you because in the smart grid, when you have integrated all the renewable energy sources, electrical vehicles are there, energy storage systems are there. Now it is a distributed system. A lot of research points are there. Only one research point I have considered is that I only have taken one kind of voltage control and torque control and just shown you that how you can design a kind of artificial intelligence controller, like a fuzzy logic controller. These are the some of these artificial intelligence role taking over in the smart grid in terms of load forecasting. Lot of a lot of work is going to be carrying on in terms of load forecasting where your deep learning or machine learning algorithms are implementing and then they are trying to be accurately try to load forecasting. This is the one direction the people are working. Renewable energy integration, because this is where I shown you one case when this wind energy system is integrated to your grid, then how effectively we try to design a controller so that it will try to be within the compliance of the grid code requirement. So that is one case I've shown you. Here your AI help to managing the variability and uncertainty in terms of solar, wind and other things. Fault detection and diagnosis also. Any kind of fault is comes also, detection is also possible. Sometimes what is happening here, you have a 500 panels are there in your wind solar farm. Suddenly one panel has damaged. Somebody has thrown a stone. One panel has damaged. The 600 panels are there. So every day you cannot go next in a spectacle. Cannot one by one panel you cannot go and see like this and cannot up and down. So if you do it every day, your time will be coming. So what the people they are doing, they have flying drones capturing the thermal some kind of images, and that thermal images they're processing to this particular artificial intelligence. Then they come to know which particular panel has a defect. This is where the people are working the role. Predictive maintenance, demand response management. That is what I told in the DR programs. Mostly DR programs where the people are trying to be adopting to working on that, doing this. And energy management system. all that is also going to be doing in the optimal power flow, voltage control, frequency regulation, real time. All these kind of the programs can be run in the real time manner. Power quality implement, AI detects and mitigates issues like harmonies, voltage cells, any kind of power quality issues can able to be detected and try to be mitigated as much as possible. Cyber security enhancement, AI-based, what we call this anomaly detection helps identifying cyber attacks, unauthorized access, smart grid communication networks. So all this data is going to be working into that. Electrical vehicle infrastructures is also going to be the AI coordinates with AI in charging and discharging, managing grid distress, support vehicle and grid to vehicle to grid operations. People are working. Decision support and automation. AI supports automation grid operation by providing intelligent decision making for operator and control centers. Just only showing the few of things in the power system and the smart grid, what the AI can do. Not only the controlling design can do with artificial intelligence, the different directions the people are working. Even data management is also the major concern in the smart grid because huge amount of data is going to be generating and where that AI going to be solve the data. So where kind of the data which is doesn't have such information can be uh, neglected or try to be diverted in somewhere. The optimal data can be stored and it can be used for the future purpose, something like that. Okay. Okay, your favorite slide has comes finally. We are waiting for this for so much of time, huh? The conclusions, of course, the power system automation is playing a vital role in the power system. And we have shown you, I started with the power system automation. What is the need? Why we are going for the power system automation? Then also we have seen the substation and distribution system automation. Then slowly I have moved to the SCADA system. And why people now saying instead of automation the SCADA? Because it is covered with the largest geographical area. And the SCADA has the different components like RTU, IEDs, master stations, right? And HMIs, and the data communication. Under the data communication also we have gone through a little bit idea about what is meant by data communication, what is node and link and connectionless services, connection oriented services, how the data packet is traveling from data control center to your RTU through a OSI reference model, something like that. Then we have seen the smart grid comparison and how the traditional grid has been converted into the smart grid in terms of distributed structure. In the distributed structure, mostly renewable energy sources are taking a major role, and I've shown you some kind of the importance of the renewable energy sources, especially wind and solar, which is in terms of statistical report with respect to India. What the India is also doing in terms of that, and some of the importance of the AI role in the smart grid, something like that. Okay. Which year you are? Third year, second year, second year. Did you have exam? Anything you want to ask?
sir.
No.
ఇప్పుడు అయిపోయింది.
It is completely so like that. What was the
No, not it.
Actually, this is majorly for the research people. Those people are working, those who are want to do some research side, right? And some faculty members be useful for this particular information.
Madam, order. Even last week,
One grid, one nation. Yes, it is initially it is already there. Already it is all the grids will be interconnected now. Then it is now it is almost in the synchronization. Even one world, one grid. That is also. We are also interconnected with Bhutan to India. In Nepal to India is there. Now we are planning to connecting from India to Iran. That will take care doing that. Whether they have to operate with 60 hertz frequency or 50 hertz frequency. If like the most of the countries, if they are operating 50 hertz frequency, then other country has to be compromised. So like that, they have to do that. Maybe we cannot say because
Record होता था.
again there is a problem. One world, one grid, war comes.
Stop it, I don't stop.
Again the problem, right? So they will stop it.
In the stream.
But one grid, one nation, one grid, maybe it is there. It's almost
Stop record is stop. Mana చెప్పండి. కెమెరా ఉంది అక్కడ మా.
you can apply for internship in a NIT. Do you have an internship program in your college? Something like 6 months or 3 months, something like that. If you have it, then you can apply in the internship for that. You can come there. 2 to 3 months you can work there. So it's also project, so not like that. Only internship, through internship only you can do. Generalize thing. It's a lunch time, right? So next time, then